Hi guys, my name is Wan and I'm from Team Pressure. Today I will explain one of the subtopics in Engineering Mechanics 1, which is Coplanar force system. What is coplanar force system? Let us look into its definition. Coplanar force system is the line of action of all forces lying in a common plane. To get a clearer view, let us look at this diagram. It can be seen that a particle which lies in this diagram is subjected by a system of coplanar forces which I denoted as F1, F2, F3 and F4. Because of the forces acted on the particle by various angles, each force can be resolved into its I and j components. In a state of equilibrium, these forces must sum to produce a resultant force which are shown by this equation. For this vector equation to be satisfied, the forces x and y components must both be equal to 0. Hence, sum of forces in x and y component is equal to 0. These two equations can be solved for at most two unknowns, generally represented as angles and magnitude of forces shown on the particles of free body diagram. When applying each of these two equations of equilibrium, we must account for the sense of the direction of any component by using an algebraic sign which corresponds to the arrowhead direction of the component along the x and y axis. It is important to note that if a force has unknown magnitude, then the arrowhead sense of the force on the free body diagram can be assumed. Then, if the solution yields a negative scalar, this indicates that the sense of the force is opposite to that which was assumed. For example, consider the free body diagram of the particle subjected to the two forces as shown in this diagram. Here, it is assumed that the unknown force F acts to the right in order to maintain equilibrium. By applying the equation of equilibrium along the x-axis, we have the summation of force in x-axis is equal to 0. Therefore, the positive F plus with the positive 10 Newton is equal to 0. Both terms are positive since both forces act in the positive x direction. When this equation is solved, we will get the F is equal to negative 10 Newton. Here, the negative sign indicates that the F must act to the left to hold the particle in equilibrium. In addition, if the positive x-axis were directed to the left, the both term will be negative. But again, after solving, F is still equal to negative 10, indicating that F would be directed to the left. Now, let's do some exercises. Here's the diagram of question 1. In this question, it wants us to find the tension in cable BA and BC in order to support the 60 kg cylinder. Some information has been given in the diagram. So when you got this question, the first thing that you need to do is identify all the forces acted on the body by making free body diagram. This is the first free body diagram that I have drawn. Due to the equilibrium, the weight of the cylinder causes the tension in cable BD to be tension in BD is equal to the 60 times 9.81, which gives the value of 588.6. The force cable in BA and BC can be determined by investigating the equilibrium of ring B. Let us look to the second free body diagram. It looks like the magnitude of TBA and TBC are unknown, but we know their direction. Next step is applying the equation of equilibrium along the x and y axis. Now we have the summation of forces in x-axis is equal to 0. Therefore, the first equation is TBC cos 45 minus 4 over 5 TBA equals to 0. Next, we have the equation of forces in y-axis which is equal to 0. And this is the equation. From the equation 1, we can make TBA equals to 0.8839 TBC. Next, we substitute this equation into second equation. Thus, we can solve the unknown and we get the value of tension in BC which is equal to 476 Newton and tension in BE is equal to 420 Newton. Let us look to second question. In this question, we can see that 200 kg crate is suspended using the ropes A, B, and AC. Each rope can withstand a maximum of 10 kN before it breaks. Here, AB is always remain horizontal. So, in this question, we need to determine the smallest angle, which is theta, that the crate can be suspended before one of the ropes breaks. Now, as usual, the first step that we need to do is to draw a free body diagram. In this free body diagram, we will study the equilibrium of ring A. There are three forces acting on it, which is Fc, Fb, and Fd. The magnitude of Fd is equal to the weight of this crate, which is 200 times by 9.81, which gives the answer of 1962 Newton. We know that the maximum of force that a rope can withstand is 10 kN. Therefore, we can see that rope AED will not break as its tension force is less than 10 kN. Next step is applying the equation of equilibrium. We know that the summation of forces in x-axis is equal to 0. So, negative Fc cos theta plus Fb equals to 0. Then we got Fc equals to Fb over cos theta. For the summation of forces in the y-axis, the second equation is Fc sin theta minus 1962 Newton equals to 0. From equation 1, we can see that Fc will be greater than Fb since cos theta is less than 1. Therefore, rope AC will reach maximum tensile force of 10 kN before rope AB. By substituting Fc equals to 10 kN into equation 2, we will get the smallest value of theta, which is 11.31 degrees. After knowing the angle, we can find the value of Fb, which is 9.81 kN. So, we have done two questions. Now I would like to summarize what we have got today. In dealing with problems related to coplanar force system, the first step that you need to do is to identify all forces acting on the body by making free body diagram. Next, the second step is you must apply the equation of equilibrium. Then the final step is you solve the equation in order to get the unknown. Here is the reference book that I have used for this video, which is R.C. Hebler, Engineering Mechanics Statics 12th edition in SI units. I think that's all for me. Thank you.